Over the last 2 decades, photonic integration has been a story of astounding success in turning the potential of optical technology into technical breakthroughs. However, applications like optical switching or remote sensing remain still at a state of expectation for an integration technology that can help them boom. What they need is a powerful integration platform that can offer low optical loss, a very broad range of optical functionalities, and high integration density in order to facilitate a very large number of processing components on chip, a kind of platform that is not available today. 3Peat aims to disrupt this scene by developing a powerful photonic integration technology with all size, functionality, and quality credentials to fill this gap. 3Peat invests on the combination of the polymer platform from Heinrich Hertz Institute called PolyBoard and the silicon nitride platform from Lyonix called TriPleX, which are both passive, very flexible, and feature low loss as motherboards in hybrid photonic integrated circuits. The project develops methodology for heterogeneous integration of the polymer material inside small depth-etched windows on triplex chips and offers the possibility for truly hybrid integration of the two platforms into single-die PICs of ultra-high functionality and compactness. For the PolyBoard section of these PICs, 3Peat aims to develop a disruptive methodology for the fabrication of a fully functional 3D photonic integrated structure with multiple waveguiding layers. For the transition of light from a waveguiding layer to another, 3Peat offers a solution based on the use of vertical multimode interference couplers. 3Peat works along a number of further key achievements on the PolyBoard and TriPleX platforms, targeting on 2 main applications, switching and sensing. 3Peat aims to develop ultra-compact 3D PICs as the basis for the development of optical switching modules that can replace their electronic counterparts in intra-data center networks, as already proposed by major players like Facebook and Google and realized by system vendors like the project partner Mellanox. The triplex part on each PIC will comprise a 16x8 matrix with lead zirconium titanate-based Mach-Zehnder interferometers. The PolyBoard section will comprise 8 1x16 MMIs at multiple layers, enabling the drop of an input stream at each output port without waveguide crossings and with minimum optical loss. 3Peat is developing a new generation of high-speed phase shifters based on the deposition of short, thin PZT films on top of triplex chips with ultra-low power consumption, 100 times lower than thermal phase shifters, allowing to further increase the integration scale. 3Peat consolidates the development of optical flex lines on the PolyBoard platform, long arrays of up to 36 single-mode waveguides for the interconnection of the active optical switching modules. Based on the same technology, 3Peat also develops a single 3D polyboard as the basis for a passive 72x72 arrayed waveguide router with 100 GHz channel spacing on the International Telecommunication Unit grid. In the same time, 3Peat aims to develop a number of multifunctional PICs as the basis for the development of integrated laser Doppler vibrometer systems to meet performance requirements in sensing applications met today only by bulk optical systems. LDV systems are typically employed in high-end applications where the precise vibration profile of a surface has to be extracted and tiny displacements across the surface have to be resolved. The photonic integrated circuits comprise both triplex and PolyBoard sections and support the generation of laser light with line width lower than 1 kHz and output power more than 10 mW, including 3 high Q-factor micro-ring resonators. The light is modulated with the PZTs developed within the project and a modulation frequency of 40 MHz. Passing through the 3D multilayer PolyBoard structure, the light exits through the optical phased array section and performs a 2D scanning of the surface under investigation with a field of view close to 12 × 12 degrees. The collected light passes through a high-performance integrated isolator developed within 3Peat with more than 25 dB optical isolation and waveguide-to-waveguide loss lower than 2 dB. The light is combined with a local reference beam and is forwarded to the photodetectors, where it is detected with heterodyne detection techniques. By the end of 2021, 3P aims to develop 2 final 3D integrated modules, one for switching and one for sensing applications. By developing this cutting-edge integration platform and the relevant system concepts, 3P aims to place Europe at the forefront of photonic 3D integration research and the forefront of switching and sensing technology, with excellent perspectives for short-term industrialization and commercial impact. In order to achieve these goals, 3P has set up a consortium consisting of 9 partners from Greece, Netherlands, Germany, Israel and Italy. For more information, please visit the 3P website at www.ict-3p.eu.